Okay, so this is number 12. So the first part, so let's read the problem. It says, let f of x be the function whose graph is shown. A friend claims that the limit as x approaches a of f of x is L. This claim might be correct or it might be wrong. You challenge the claim by proposing a particular value of epsilon. Your friend's claim is correct. So if my friend's claim is correct, then the actual limit as x approaches a is L. So this would be my actual limit, so this is L. This would be the value, the A. And on the diagram, indicate possible values of A, L, and epsilon and delta such that your friend successfully meets the challenge. Okay, so we are going to choose an epsilon. And remember, epsilon is the distance away from the limit, so this will be L plus the epsilon because we went up, and then we're going to go the same exact distance down. So this is my envelope. So I will want to pick a delta value so that my f of x stays within this envelope. Okay. So I want to, it's kind of linear, but I want to pick delta so that it's gonna guarantee that I'm gonna be inside. So it doesn't ask you for largest, so what you can do is just equally go away from the A. So that distance that you're going to go away from A is going to be the delta. So this is going to be going left, A minus delta, and A plus delta. And you know that this is correct because what's going to happen is for this epsilon and this delta, my f of x will be inside of my envelope. So this is the actual limit. So that's how you know that this is good. Okay? Alright, so then part B, it's the same exact question, however, my friend's claim is wrong. So let's start with that. So if my friend's claim is wrong, then the limit that my friend thinks is the limit is not actually the limit. So I'm going to do this first. So here's a limit, and this is not going to be my A. I'm going to move my A over a little bit. So obviously the limit as x approaches a of f of x is not actually the limit that we show here. But our goal is to pick epsilon and delta such that our friend successfully meets the challenge with the value of delta. So we still want to be within the envelope. Okay, so let's see. Here's going to be my epsilon, and it should go equally above and below. So we go above, we go below. So here's my envelope. Delta has to be the distance that we are going to move to the right and to the left. Now we have to pick a delta so that our friend's error is not actually obvious. So we want to still be inside this envelope. So we're going to go just a tiny bit to the left and just a tiny bit to the right. So this is going to be A minus delta, and this is going to be A plus delta. So here's my function. I'm still inside the envelope, so the epsilon was too big. If it gets smaller, you'll notice that there's nothing that I could do to stay within the envelope. So if I pick epsilon really, really tiny, I would actually be able to expose my friend's error. But since we picked a rather large value, that we are incorrectly showing that this is actually the limit because we were able to find a delta so that our function stays within this green envelope.